I'm very pleased to be able to come here to Stockholm and to speak to your user group. As he was saying, my father's family is Swedish. My wife and I are from Minnesota, and of course Minnesota has many Swedes and many Norwegians, and we all call ourselves, we're Norwegian American or we're Swedish American. I happen to be both because my mother's family is Norwegian, my father's family is Swedish. My father's family came from Småland around 1870. And they moved to Minnesota because Minnesota was nice and cold, just like Sweden. And in fact, many times I think Minnesota is colder than Sweden. My wife, Donna D., is also here. She's sitting in the back. And this is our first visit to Stockholm. I did visit Småland in 1964 with my parents when I was kind of young. And this is my first time back to Sweden since 1964. And we are very pleased to be here. And we hope that we would really like to have some business in Norway and Sweden. I do some teaching, and I do some consulting. I do some performance tuning with analysis services. And we are very much enjoying being here, and we would like to come back. Here's a little bit about myself. I started out with analysis services back when it was called OLAP services, back in SQL Server 7. I wrote the second book that was published on Microsoft OLAP called Microsoft OLAP Unleashed. Then I wrote a book on SQL Server 2000 on data transformation services. Then I retired. I have not written any books since then, but I did. I am one of the authors of a course on MDX for solid quality mentors. And now I'm one of the authors on this Maestro course, which we've taught, which then I was also one of the teachers for that course the past 3 weeks. I work through Solid Quality Mentors, a worldwide organization of 130 mentors. Solid Quality has not done a lot of work in Sweden. There are a few courses have been offered, but not very much. We're very strong in Spain and Portugal and Italy and in the United States. My personal specialties are, again, working with MDX, tuning analysis services, and then doing development on data warehouses. My presentation today is really presenting some information about the course that we offered that I helped teach this past 3 weeks for Microsoft. For a long time, there's been a master's program for the SQL Server database engine, the Microsoft Certified Master in SQL Server. Last summer, the SQL CAT team, the customer assistance team, approached Microsoft Education and asked if they could do a course, a master's program also for analysis services and for business intelligence. Microsoft Education did not agree to do that. Microsoft is a big company and they're very busy doing all sorts of things. So the Microsoft sales team, together with the customer assistance team, decided to put together a course like the SQL Server Master's course on their own. And they called it the Maestro. Maestro is Italian for masters, because they couldn't call it a master's because Microsoft hadn't officially approved it. So they contracted then, the Microsoft sales team contracted with Solid Quality Mentors. I and some of the other people at Solid Quality Mentors helped write it. And then the past 3 weeks we've been teaching it, first in Redmond at Microsoft's headquarters, then in Hong Kong, and last week in London. Microsoft was very surprised to see the level of interest in this course. There were almost 500 people that applied to attend, and they only accepted about 90. And in London, there were only 14 seats in the classroom. So we had a very small group in London. Did any of you here apply to take this course? Nobody did. Okay, a few of our, I gave this presentation a couple of days ago in Malmö, and a few of those had applied and the course had not been accepted. The folks at Microsoft are now reviewing this program and looking at the large level of interest in it, and they are considering whether or not they're going to turn it into an official course, whether they're going to have a master's program for analysis services, or whether they're going to continue on in some other way. And right now, they really haven't decided. But because of the level of interest, the number of people who do want advanced training in analysis services, it does look very likely that they will do something additional with it. Here's just, I have a few more slides about the Maestro class before I get into the main part of my presentation. We went over the latest information that's available about analysis services, and especially focused on designing large cubes, because organizations are working with larger and larger data sets. Microsoft is trying to push into the large cube area. And there are some different strategies that are needed with analysis services when we get into a larger amount of data. And just again, one of the keys for people who successfully complete this program, Microsoft is saying that they will be analysis services masters if and when Microsoft actually makes that a certification for analysis services. The requirements were quite extensive, and they did include doing a case study. So of our 90 participants, we don't expect that all of them are going to successfully complete the course. There's a test they have to pass, and they have to do a case study, and they have to demonstrate that they are able to work either with large cubes or with a complex analysis services database. Here are the topics that we went over in the course. Actually, as we taught the course 3 weeks, the topics changed every week, because again, we developed it and we started to teach it, and we got a lot of feedback, and we were changing it as we went along, because it's really it's a very interesting thing when you say, what are we going to teach people who have at least 7 years experience working with analysis services? What are we going to tell them? Well, we found a lot of things that we could talk about, and it's interesting. I know the course that we came up with, I teach a 4-day introduction to analysis services. I teach a 3-day MDX course. We didn't talk about any of the things that we normally talk about in a course on analysis services. We found a whole bunch of different things to talk about, and in fact, everybody on the team wished that we had made it a 5-day course instead of a 3-day course, because there ended up being so many things to talk about. Now, what I'm going to do in my presentation today is kind of really, there's three separate focuses of my presentation today. First of all, I'm just going to talk a little bit about analysis services and the Microsoft BI strategy, where it is now and going on into the future. Now, this wasn't really a topic in the Maestro course, but it was something that was talked about a lot in the last 3 weeks. People asked a lot of questions, and the Microsoft people who were involved in the course tried to answer them. And I know, especially as I speak to a group like this, I guess I expect that most of you work with analysis services. I expect there may be some people here who don't work with analysis services as much, but I would expect that all of you are interested in what Microsoft's strategy is going forward with analysis services. Just, how many of you do work with analysis services? Could you raise your hand? Okay, so it is most of you work with analysis services, not quite all. Those of you who don't work with analysis services, some of this talk is going to be kind of boring, kind of inside it, but there's some technical details. But this first section is really just kind of an overview. The second thing I want to talk about is I have a list of key themes, and in fact, here they are right here. These are the topics that, it's not the outline of the course, but it's the things in the course that we kept coming back to again and again for important topics that for people who are working with analysis services, and especially as the cubes get larger and larger, these are the things that Microsoft, the Microsoft Customer Assistance team, and other folks who have been doing this sort of work, it's the sort of things that they think are really important. So these were kind of some of our big themes, and I'll be speaking briefly about each one of these. And then the third part of my presentation is some quick suggestions, because you weren't able to take this 3-day course. I can't give you the whole 3-day course, but there are some things that I learned and that I saw other people learning that, people who are experienced, but there are some things that they didn't really know about or didn't understand too much. And so I have this set of suggestions that even though you don't get the whole course, there's some practical things that you may be able to apply in your own situation. Just going back here then, I have some disclaimers here. This is not the same material as was taught in the course. The Maestro's course was developed by and for Microsoft, but this presentation was not. So we're here at Microsoft's headquarters, and but this is not something that Microsoft has approved, what I'm saying here today. Third, some of the material in the Maestro's course was covered by non-disclosure agreements. All of the participants were required to have an NDA in effect. But of course, we're not going to be talking about any of that here. So I imagine many of you do have an NDA with Microsoft, but we won't be going over any of those things. It wasn't a lot of material, but there are hundreds of configuration parameters with analysis services. Most of them are undocumented. And we were told about a few of them that they're not documented, and we were told that we couldn't tell anybody else. So I don't know they're afraid that people are going to go off and really break things by using these parameters, but that's what was covered under non-disclosure. And it was a 3-day course. It should have been a 5-day course, and here we have it in 2 hours. So we'll do as good as we can. So let's get to it then. The first topic, analysis services in Microsoft's business intelligence strategy. Microsoft announced, well, of course, it's several times, but especially last fall at the PASS conference in Seattle, they announced a change in their strategy, or actually a new part to their strategy, that they were going to take what's being referred to as BISM, the Business Intelligence Semantic Model, the model that's used in Power Pivot in Excel 2010. And they were going to push that into the next version of SQL Server. Now, I was there in Seattle when this was announced, and that was quite disturbing to me and to other folks that have spent a lot of time working with analysis services, because it sounded like the analysis services that we know and we've worked with for years was kind of going to be replaced by this new model. And there were some people, Chris Webb from London, who did some blogging about that, and there ended up being a lot of discussions about it. And there were the last 3 weeks as we had this class. A lot of people were talking about this. We're challenging the Microsoft personnel. Are you really going to support analysis services, or what's called the UDM, the Unified Data Model? Are you going to be continuing to push this on into the future? Well, what Microsoft says is that they are going to do it. And they are talking about the investments that they're making, and they're talking about putting it together on a parallel track. That we have the new BISM model, that we have the old UDM model, and the way that the two of them are going to work is that for new development, for small and fairly simple cubes, Microsoft is expecting that BISM will be used, because they see it as being simpler and easier to develop in BISM. Now, whereas the UDM, the old analysis server model, will still need to be used for larger cubes and more complex cubes, specifically when there's not room to keep all the data in memory at the same time. The BISM model, the new model, it's an in-memory cube model. It requires that all the data be able to be held in memory. And Microsoft sees, that that's, in fact, can be done for a lot of the cubes that are being developed. But there are also cubes that organizations need that use so much data that all of it cannot be held in memory, and therefore those projects will still need to be done in the UDM and the traditional analysis services model that we've been using. And the expectation is that they will be doing this on into the future, and they are going to continue. Microsoft is promising to continue to develop the UDM, make improvements to it, so they can support large cube development on into the future. The other thing, of course, is that BISM right now does not contain all the features that are available in analysis services. It uses the DAX language, the DAX language, as opposed to the MDX language. And DAX is, again, it's supposed to be easier, but it can't do everything that MDX can do. So the vision, it might be able to do more and more on into the future. And certainly Microsoft is putting a lot of effort into this, into the new model. But for now, at least, if there's a complex project or if there's a large project, it needs to be used. We need to use the UDM. The smaller projects, the new projects, the simpler projects, Microsoft is expecting to be done in BISM. And some people are actually moving projects from from the UDM over into BISM. But my sense is that the people at Microsoft really don't expect that to happen too much. It's more a matter of when there's a new project. And if it's small enough, if it's not complex enough, they expect that to be done in the new model. And of course, we'll see how that all plays out with the next version of SQL Server coming out and see how strong that is. A few other things with analysis services. There are some new opportunities with analysis services. One of them is using analysis services with solid-state drives. And that's actually a topic we talked about a lot in the last 3 weeks, and I have a bunch of slides on it later on, just mentioning it here. But there are tremendous possibilities with switching analysis services from using hard disk drives over to the solid-state drives. Two other things, Rollup and the Parallel Data Warehouse. Microsoft has a new version of SQL Server called the Parallel Data Warehouse, which is basically a bunch of SQL Server relational database engines running on different computers. And the Parallel Data Warehouse brings all this information together and assembles it in a high-performance sort of way so that you can have the data warehouses that have the amount of data in the hundreds of terabyte range. And with more in the future, going up higher and higher. Now, that's on the relational side. But what's interesting is the possibility of using analysis services to point at the Parallel Data Warehouse, using Rollup, using the relational storage model, and pushing analysis services to a level of displaying amounts of data that it's never displayed before. And that hasn't been done yet. In fact, they're still working on getting the driver to hook analysis services up to the Parallel Data Warehouse. But I know it's something that I think is a very interesting possibility for the future to bring analysis services into the very large data warehouse area. Then finally, the new version of SQL Server, the next version of SQL Server is going to use columnar indexes, which is basically, there are other people who can maybe explain that better than I can, but it's kind of like pushing the multi-dimensional speed back into the relational database. And so SQL Server, the database engine, will be able to do things quickly. We'll be able to aggregate data with the speeds that were previously only possible using analysis services. Now, in a way, that would seem like there's some competition there. But what's going to happen is that with analysis services, again, using ROLAP, you'll be able to hook up to SQL Server with these columnar indexes, and we'll be able to, again, push to a much higher volume of data than we currently have with analysis services. But those, I mean, these are things for the future. But I know, as somebody who has, I've worked with analysis services for a long time, and I'd like to continue working with analysis services for a long time. And I think we have some very interesting possibilities here on the horizon. Okay, that brings me back to the second main area, to the key themes for the Maestro course. Before I do that, though, are there any comments about this, about these new opportunities, or about the whole BISM, UDM? Anybody have some comments about that? Comments or questions?
One question.
Sure.
Large cube. What do you consider a large cube?
Okay, question, yes. What is a large cube? What do we consider a large cube? I heard that question answered in two different ways in the past 3 weeks as we've been teaching this class. From the perspective of the Maestro class, where you really need to use special attention in working with cubes, it becomes a large cube when it reaches somewhere around a terabyte of data. If you have a terabyte of data, the analysis server data, when it's, your MOLAP files, all the files have reached a terabyte, then you've really got a large cube, and you have to really change the strategy that you're using with analysis services to make it work. And you may be well at half a terabyte. It kind of depends on the structure. Well, it's, the larger it gets, the more careful you have to be to get good performance out of analysis services. And I'm sure many of you have seen that. Analysis services has been improved over the years, so performance improves, but there still are size barriers. As you get larger cubes, things get slower. Sometimes the server runs out of memory, and so forth. In terms of the split between BISM and the UDM, what I've heard the Microsoft people say is that they expect cubes that have under 100 gigabytes of data to be using BISM. And they see the 100 gigabyte and higher, the new to continue to be UDM, but for new development where the structure is not too complex and there's no more than 100 gigabytes of RAM. But the key there is, can you put all the memory, can you put all of it in memory? So if you have smaller servers, you're going to have to stay with the UDM for your cubes. If you can have servers that are powerful enough to keep all of it in memory, then you can build larger cubes with BISM. That's right? Okay, very good. Other questions or comments? Okay, very good. Let's get on then to the content of the course, or I should say the key themes. And again, here they are. We'll be going over them one after the other. First of all, random I/O and solid-state devices. We spent more time in this Maestro's course looking at the internal structure of analysis services and its operations than nobody's ever spent as much time on this before. I mean, it was very interesting to talk about how analysis services work. Sometimes, it's maybe we even talked about it too much. But there are some interesting things that come out of understanding how analysis services works. One is, and I'm sure many of you know this already, is that analysis services uses a lot of files. I mean, it stores data in the file system, and it makes a lot of files. It makes a lot of files when you process the cubes, and it has to access a lot of files when it reads the cubes. Also, when analysis services is reading data out of partitions. The partitions are divided up into segments. And so you send off a query to analysis server, I need the data from this particular month. It goes to all the partitions that have data for that month. It goes to the different segments, and it can start off literally hundreds of different threads, all reading data at different places on the disk. So data read from one segment, of course, will be in order, so that will be sequential. But there are so many different reads being done at the same time that essentially the disk is receiving random I/O requests. And solid-state drives do a whole lot better in responding to random I/O requests than hard disk drives. And it's pretty obvious. The hard disk drive requires a mechanical movement of the head. It has to move back and forth, and the disk has to spin to the right place. Things have to move in between every single read. And so if you're jumping all over the file system to read files, you lose your performance. SQL Server, the database engine. I mean, all of us who work with analysis services also work with the SQL Server database engine. SQL Server database engine works very differently on that. You can get very good sequential reads from the SQL Server database engine, but you don't from analysis services. You can get 1,400 I/Os. Let's say you can get 1,400 I/Os per second from a hard disk drive using sequential access. The same hard drive, you can maybe only get 100 I/Os per second with random access. And whereas a solid-state drive can deliver up to 4,000 IOPS. Got a chart that shows that. Hard disk drive sequential, hard disk drive random, solid-state drive random access. It's almost like analysis services. Whoever decided to do things like this originally, it's almost like they were looking ahead into the future, and we're seeing these solid-state drives because it fits. Analysis services fits on solid-state drives. Now, one of the issues with solid-state drives, of course, enterprise-level solid-state drives are still fairly new. And there are very few analysis services projects that are using them so far. None of the clients that I currently work with are using solid-state drives. But the business model for this, the argument for this, I think is so strong, is that we are going to be moving to solid-state drives in the near future. And when a business does their economic calculation on this, they're saying, how much storage can I get for a certain amount of money? Well, if they're asking a question that way, well, hard disk drives, of course, are a lot cheaper. You can get a lot more storage on hard disk drives for the same amount of money. But when we're talking about analysis services, we're talking about retrieving data quickly. We're talking about getting queries that can bring the data back to folks. And with analysis services, we're thinking about our hard disk drives. We have to look at it as a way of how much does it cost to return data quickly to the end user. And the cost comparison between a hard disk drive and a solid-state drive is enormous. And you see it with a time taken for querying. Here is this chart is taken from a SQLcat paper. It's available on the SQLcat website. It's one on distinct count, using solid-state drives for distinct count. And the chart here shows the length of time it took queries to run. The big blue line is the hard disk drive, and the short ones are two versions of both using solid-state drives. And the three different points on the chart, this is running 6. Sequentially, this is running 6 queries all at the same time. Here's running 12 queries all at the same time. The more, and of course, the more people who are running queries, the more simultaneous queries that are sent to analysis services, that makes it more and more random access. And so you get better and better gain in performance from the solid-state drives. Is anybody using solid-state drives with analysis services now? You are. What's your experience with it?
It was slower.
It was slower. Well, there, that takes care of that subject, doesn't it?
We're working on it. It's in a lab experimental environment, so we're just putting some time in.
Okay. Anybody else have any experience with it? Okay.
We use that paper for the.
You use the paper here that it talks about here. Okay.
It's still mounted in the sand, which kind of defeats the whole purpose.
It's mounted on a sand.
Yeah.
Yes. Yeah. You know. Yeah. The last 2 weeks, the first week, some of you people maybe know some of these folks. The first week I taught in Redmond together with Denny Lee and John Sermon from the SQLcat team. The last 2 weeks I taught with Thomas Kaiser, who happens to live in Malmö. And Thomas is very opinionated about that. I mean, he doesn't think that analysis services should ever be run on the sand. And it should be direct connect. And of course, it should be solid-state drives if possible. But as I said myself, I haven't done this with a customer yet. This is new. The promise of it, I think, is huge. And when you understand how analysis services uses random access, that's the reason for it. Yes?
Tim, just I don't know if I was not paying enough attention, but what's the difference between the SSD and the SQLcat SSD?
Not much. Not much. Yeah, and it's just in the paper if you read the paper they had, they tested in 2 different ways. In this case, there's very little difference. The chart would probably be better if they were taken off because there's no significant difference between those 2 bars. Okay, anybody else? Okay, next topic. So we already talked about hardware, of course, with the I/O. I/O is tremendously important with cubes, and it gets more important as the cubes get larger and larger. More effort has to be put into looking at the I/O patterns that analysis server is using. But it's also important to look at the memory that's available to the server, the threads, more processors. Analysis server can use more threads. The more threads that the analysis server can use, it can respond to more queries more quickly. There are a number of ways that thread usage and memory usage can be optimized. There are a lot of configuration options, some that Microsoft encourages us to look at, encourages us to change. There are many more in the configuration file that Microsoft says don't touch them. But there are various things that can be done to affect how the memory and the threads are used. Now, again, we spent a lot of time on this in the course. But the bottom line is analysis server needs a lot of memory. It needs a lot of threads. And sometimes the only way to get better performance is to give it more memory, to scale up the servers that it's running on, or of course then to scale out, to take your analysis server database and to move it to multiple servers where each server receives some subset of the queries that are being sent to analysis server. So instead of having one server that's receiving 100 queries at the same time, you would maybe have 5 servers, each of which is getting 20 queries, which of course means there's going to be more memory and more threads available for each one of those queries, and they can be handled more quickly. So we are going to look at a few things about changing the memory settings later on in the third part of my presentation. Okay, switch topics again. Another theme. Get away from the hardware. Get back to the design of the cubes. And this is, I said our course didn't go over anything we would go over in the beginning analysis server course. Well, this is kind of an exception. Certainly in the beginning analysis server course, you talk about attribute relationships and natural hierarchies. I guess the difference in the course, in the Maestro's course, is, and it was really striking how this came up over and over and over again as we looked at different aspects of managing analysis server. There's something about having natural hierarchies. There's better usability. It's better for a user if they can start browsing a cube, and when they pull out a hierarchy, they don't see 1,000 members or 10,000 members, but they see a higher level of that hierarchy. They see maybe 15, maybe 100, whatever. And if you can have levels where the hierarchies, where the attributes are related to each other, it's really, and of course this fifth bullet point, it's the way OLAP was designed to be. Sometimes I think it's important if we just sit back and think, well, why are we doing what we're doing with analysis services and with BI, or more specifically, I suppose, with what is called OLAP? Why are we doing this? We have all our data in our relational databases, but I think there's something about the human mind that we can't, data in a normalized sort of form is really not friendly at all for a human mind to understand. The point of OLAP, the point of multidimensional analysis, is people like to see things in buckets. They like to see things in categories. They like to see things summarized. And they like to be able to see things in the big picture and then drill down to more details. That's what we're doing. And so if you have an analysis server cube, if you have your dimensions and you have a bunch of separate attributes that aren't related to each other, well, you haven't really used the model. You haven't really gotten it the way it's supposed to be. And it doesn't work very well. And here's some more of the technical details about that. If you have natural hierarchies where the attribute relationships are well defined, your aggregations become multi-purpose. You build one aggregation, or you include, say, one attribute in an aggregation, say, such as perhaps the day level of a time hierarchy, of a date hierarchy. You include the day level in, well, then that day level can also be used for weeks, for months, for quarters, for years. You can have one attribute that gets used multiple times. If you have separate independent hierarchies, separate independent attributes that are not included in hierarchies, or if they're in hierarchies where the attribute relationships are not defined, then every time you put an attribute into an aggregation, it's only useful for that particular attribute. So there's just the aggregations work better. You have more efficient processing, and the processing uses less total memory. We have one of the labs for the Maestro course has a poorly designed dimension that cannot be processed with the amount of memory on the machines that we were using. And it was a poorly designed dimension that was very easy to design. I designed it. I went into the wizard and I said, I want a new dimension. I want to include all the fields as attributes, and I want to build this dimension. Very easy to do. And it absolutely would not process. It ran out of memory, and the processing command was canceled before it completed. Well, what do you have to do about that? You have to, well, number one, you have to throw away all the fields that should never have been attributes in the first place. And the second thing is you have to establish attribute relationships, because when a dimension gets processed, all of the attributes, it goes through a chain. It starts with if you're talking about hierarchies, you think of the higher levels of the hierarchies first. It does those first, and then it kind of works down toward until it gets down to the key attribute of the dimension. And all of the attributes related to any particular attribute have to be held in memory at the same time. So if you have no attribute relationships defined in your dimension, all the members from all the attributes have to be held in memory at the same time. And if you have a large dimension, well, we just had 11 million member dimension. That's not, well, it's large, but not, I mean, I've seen larger. It could not get processed because all of that attribute information could not be held in memory at the same time. So we had to establish attribute relationships, and in fact, one little trick that we talk about with that is we actually put the key of the dimension key in as an attribute a second time and related half of the attributes to that, and then related that one to the key attribute, which takes the memory pressure off processing all the attributes simultaneously. A few tricky things there, but important. Okay, you get faster querying. Even if you don't have aggregations, because of the way analysis services builds indexes, you get faster querying if you have defined natural hierarchies than if you have not. So finally, the bottom line here is use natural hierarchies. Even if you have to manipulate the source data to do so. Not change the source data. I mean, not be dishonest about it. But, there are times that, I don't know if you've seen this or, but where you almost have a natural hierarchy, but there are some members that just don't quite fit under their parents, or they fit under multiple parents or something like that. Well, if you've got to manipulate your source data to add some other value in there so that you can divide it out, you should do it. As much as possible, do natural hierarchies. And the bigger your cube is, the more important that becomes for all of the reasons that we've discussed. Any comments, questions about that?
I didn't understand how you use the key of the dimension. You said you use the key of the dimension as a part of the hierarchy? Or?
I'm sorry, I didn't quite hear that.
I didn't understood when you said that you use the key of a dimension.
Yes.
You have a dimension, you use the key as part of a hierarchy.
Yeah. I think that's kind of interesting, and after the break, I'll pull the example up and I'll show that, because it's easier to show it than it'll just take me a couple minutes to pull it up. So I'll do that after the break. I'll start out after the break by showing how we redesigned this one way to help with that attribute pressure. Okay, I'm going to try to get a couple of other topics under the way before we get to the break. Push calculations into the source relational database when possible. This was a theme that came up many different times. And it kind of relates to this next issue. Larger cubes require simpler structure. And I'll talk about this one first, and I'll get to the other one. The point is that the larger and larger the cubes get, a lot of the wonderful things that Microsoft has given us, a lot of the wonderful features that we have in analysis services become less practical. And we kind of have to go back to the more basic functionality that analysis services provides us. In other words, that we have dimensions and measures and so forth. And there's some specific things here. If you take Microsoft Excel, any version of Excel, and you hook it up to a cube, and then you go on and you say, I want to do some custom grouping here. There's a custom grouping functionality in Excel. What happens is that Excel generates a create cube command and actually rebuilds the whole cube for one particular session. And, and then the next time you open up that Excel spreadsheet, it maybe takes 5 minutes, 10 minutes. You seen this? I mean, why does it take me 10 minutes to open my Excel spreadsheet? Well, a cube is being built right in front of your eyes as you're waiting. And it doesn't tell you that's what you're doing, but that's exactly what it's doing. So, and we can't stop our users. There's no way of configuring analysis services to say, don't let Excel do this to us. But if we know that that's happening, if we see that's happening, if we have users that need a particular grouping that's not currently in our cube, well, we should put it in there. We should make a hierarchy that fits the members in the way that the users want to do the grouping. So then, of course, it can perform very well. Consider replacing MDX calculations. That's too bad because I really like MDX. But if you have too much MDX, in your script, or if you have your calculations are too complex, the larger and larger the cubes get, the more difficult it is to perform. Even some people, I guess it's one of the examples that Thomas Kaiser gave, that he preloads values for year to date. He calculates them all out. Well, if you do that, you can give, again, much quicker response time. The values are already calculated. The problem with doing that, the problem with doing any of these things, is that you lose some of your flexibility. And it might not work across all dimensions or from all perspectives. And it just gets trickier and trickier. But it needs to be, you need to be thinking about that in your design as you're working on performance. And then replace last non-empty aggregation with values loaded in the data mart. So that, well, last non-empty is a type of aggregation where you say, you know, if there's no value for sales in March, I want to see the sales for February for this particular store. If there's nothing for either March or February, I want to see the ones in January. I want the last non-null value. Well, and that's important if you have an organization where not everybody reports at the same time. So you want the most current report from every part of your structure. But you can quite easily do that by adding another field to your fact table. And where you have nulls, you just pull forward the last non-empty value and push that into for your current value. So there's a number of these things to help improve performance if that's what you need, if your cube's getting so large. And then coming to this next chart, or this next slide, if you really have a large cube, you should not be using parent-child hierarchies, unary operators, many-to-many dimensions, reference dimensions, junk dimensions, and degenerate dimensions. I'll say a little bit about each one of those. Parent-child hierarchies, of course, is an interesting one. A lot of it depends on how large the parent-child hierarchy is. There's a warning. You get a warning in analysis services if you have more than 500,000 members in a parent-child hierarchy. That warning is way, way overdue. 10,000 is the better way of looking at the maximum number of members in a parent-child hierarchy. Again, Thomas Kaiser's opinion on this: you never need a parent-child hierarchy. Is there ever a parent-child hierarchy that you can't throw away? Throw it away. Convert it into a regular hierarchy. So now, I mean, many of us use parent-child hierarchies. I use parent-child hierarchies, and they will work okay. I mean, how many of you use parent-child hierarchies? I mean, they can work okay, but they do become a problem when they get too large. Unary operators, you have the plus, the minus, you have the ignore. They can be replaced with either in the fact table with manipulating things, or they can be replaced with some MDX scoping in the MDX script. As with parent-child hierarchies, though, when you replace them, you don't get exactly the same functionality as you otherwise had. And so there are business decisions on whether to replace them. But say, like with unary operators in particular, when replaced with MDX code, script code, performance is nearly always greatly improved. So, but it's, of course, obviously it's more work. Many-to-many dimensions. Again, how many of you use many-to-many dimensions? Many-to-many dimensions is a wonderful, really a revolutionary improvement of analysis services. It came in Analysis Services 2005. It's useful for all sorts of things. But it can cause a performance problem because it has to always, the many-to-many relationship, there's an intermediate table, and it always has to be resolved at query time. So every time it's querying, it's going to this table, the intermediate table and the final table, and retrieving this data and assembling it. It can shoot query performance. It can destroy query performance. Now, there is a boost that's available to many dimensions, and that's called the matrix optimization technique. Have any of you used that, matrix optimization? The general, you've tried it? Has it worked for you?
I haven't fully applied, but it will work.
It will work. Okay, good. It will work. It does work. There are people that talk about 100-fold improvement in the speed of their queries by using matrix optimization of a many-to-many dimension. It basically takes all the possible combinations and puts them into the intermediate table. And anyway, there's some good papers out on the internet explaining how to do that. Even that, though, it works better with some many-to-many dimensions than others. It depends on the data characteristics, how many unique combinations of values there are. It won't always work. But if your data is configured in a certain way, it can work. It can work very well, and it gives you a many-to-many dimension that performs well, and it still is the same. It looks the same to the user. The other thing that can be done, of course, with a many-to-many dimension is to expand out the fact table to cover the many-to-many relationship. Meaning that if you have visits to a doctor, and the visits have you have a reason for the visit, and it's a many-to-many dimension because sometimes a person comes to the doctor, he's got 2 problems or 3 problems. So then you have to have a many-to-many relationship to cover those 3 issues. Well, you could change the grain of your fact table to have one record for every reason for every visit, rather than just having a record for every visit. And that causes problems in other areas, but it can greatly improve performance. Reference dimensions, again, no reason to ever use those. And they're very, of course, that's quite easy to get rid of. I mean, a reference dimension is a convenience in development, but there's really no reason to do it. A junk dimension is when you throw a bunch of unrelated attributes together into a dimension where there's no relationship between any of them. I happen to really like junk dimensions. I use junk dimensions, and I have very good luck with them. But again, that kind of gets back to how many members do the attributes have? How complex do you make it? I personally think it's. Some of the Microsoft folks were saying never do a junk dimension. I would personally prefer to take a group of small unrelated attributes and throw them in the same dimension. Rather than having a bunch of separate dimensions. Degenerate dimensions, when you take values from the fact table and make a dimension out of them, it's like just an invoice number or something. Again, there's a number of problems with that. And of course, one of them is just as you have dimensions that get too big. And do you really need those dimensions? Or should you really be doing it? Maybe you should really be doing that with drill through rather than making a dimension out of it. Okay, use a pure star schema in the source relational database. Be careful with the complex to the MDX script and the calculations. Again, I like MDX. I like putting things in MDX script. I have an MDX script in production that I copied into Word, and it's 400 pages long of wonderful MDX script code. And that performs fine, except when I open up the bids. Opening up the bids is a pain because it has to load all that up. But there's code and then there's code. Using named sets can really slow down your cube in some ways. And the MDX scripting where you're using scope statements to apply things, I mean, that usually performs just fine. So it all depends on how you're using it. And I'm a little past 3 here, and I think I might as well stop right now for the break. Is that?